Hey everyone, so just wanted to share a CodeWars challenge that I did yesterday, and I managed to get it compressed down to a ridiculously short one-liner, kind of trolling everyone by how much shorter it is than everyone else's. Yeah, so that's a pretty short one actually. There's lots of quite long ones. Mine's a nice little one-liner. Yeah. So coming back to my solution, it's this little guy. So we got some juicy things in there, a bit of a regex. I'm using eval. Terrible thing to use. Don't use this, like, ever. But to keep it short, I am using it for some reason. So this circles around a game called Greed. It's a dice game played with 5 six-sided dice. Your mission is to score your throw according to these rules. So there are points awarded for different combinations, and the goal is to essentially return the correct number of points for the dice that you are provided in an array. A single die can only be counted once in each roll. For example, a given 5 can only count as part of a triplet, contributing to 500 points, or as a single 50 points, but not both. So basically, 1s and 5s are special because they are the only numbers that actually count individually. All of the others do not count on their own. And for each of the numbers, if you have 3 of a kind, you are awarded a number of points which exceeds the usual amount. So instead of getting 50, you would get 500 if you have 3 5s. And if you have 3 1s, then you get 1,000. First thing I observed is that there's no advantage ever in choosing 1 over 3. If you have 3 available, you get more points. So always use the dice as a 3 rather than individually. And it's quite a simple algorithm just to add up all of the relevant things. But as discussed, I'm using a regex and I'm using evaluate. So I'll get on with how that kind of makes sense and how it helps to make the algorithm very concise. First thing I thought would be a good idea was just to sort the dice values. The reason being that then naturally groups the same values together with each other. So I'm just going to write the code for that. Okay, so I'm sorting the dice. I'm doing this here because one of the requirements is to leave the input array unmodified. So I'm just creating a duplicate array here. And you can see here we have the sorted array. So now as a human being, you could just quickly eyeball it and say, hey, I've got 3 of the same kind. I mean, you could probably do that anyway quite easily without it being sorted, but having them grouped means it's quite easy to spot a sequence of 3 that are the same. And now you can kind of see how you might be able to use a regex to be able to spot that you've got 3 in a row. If we convert the array into a string, then you can do a regex match against a number and then check using a back reference that that number is repeated twice for a total of 3 times. So I'll write that code now. Running this then, we get the sorted string. So this is a bit of a hacky way to convert an array into a string. So the fact that I'm adding it to a string means JavaScript knows that it needs to concatenate it, so it calls the toString method on the array, which just delimits the array with a comma. So you'll see here in the output we get the array delimited with a comma and then concatenated with a comma on the end. And then I'm doing my match, and if we look here, you've got a a capturing group here, which matches any character followed by a comma. And then I'm using a back reference to refer to the first capturing group, and then a comma, and then the first capturing group yet again. And as you can see, given this example, there are no cases where there are 3 characters, 3 digits in a row that are the same, so we get null. But on this example, because we have 4444, we match that string of text. Now, I had the idea that I might be able to be cunning, and rather than just extract the match, I could replace the match with the value of the points that corresponds to the specific matched group of 3. So, for example, my matched group of 3 4s maps to 400 points. And you can see that the number of points matches the value of the dice. So we can use that to our advantage. So I'm just going to write the code now to replace this match call to instead do a replace, which is going to replace the matched group of 3 dice values with the points value. Okay, so you can see that that is working on this one where we've got 3 in a row. It's being replaced with the value of 400. So the way that this works is you can pass a replacer function to the replace method, and rather than using the first argument, which is the match, you also get the match groups as arguments to this function as well. So this S is going to be whatever character was matched here in this capturing group. So given it's a number, it will be the number 4. It'll be the number 4. I can just do 4 multiplied by 100, and this will give us the number of points. Now, there is a complication with the number 1, because 1 multiplied by 100 is not 1,000. So 1 is exceptional in this pointing system. So we need to do something to take that into account. And all we need to do is just add an exceptional case for the scenario that S is 1. So there we go. I've just added a little bit of logic here that adds a ternary that checks if S equals 1, then we're going to use a value of 3 here, otherwise use a value of 2. And it's just doing 10 raised to the power that is the result of this expression. So raised to the power of 3, it'll be 1,000. Otherwise, it'll be raised to the power of 2, and it will be 100. And you can see here, so I've used this attempt button just because it's got more test cases. I get 1,000 in the case of a sequence of 3 1s, and in other cases, like here, we get 600 for the sequence of 3 6s. The next thing to do is to handle the individual numbers. So where it's not a group of 3, we need to insert the number of points that are required for each individual number. Now, we already know that it's only 1s and 5s that earn points on their own. So we just need to add another replace that inserts the correct number of points for 1 and 5. Okay, so this shows that quite nicely. I'm just using a replace here. I'm matching either a 1 or a 5 followed by a comma. And then I'm just using another replacer function here to just check the value of S. If it's 1, then we set the points value to be 100, otherwise we use 50. In addition, you can see how the two replacements work quite well together, because this first replacement is happening on the first 3 characters, so that nicely takes into account the fact that you can only have one group of 3, and then it will finally replace the one that is remaining. Outputting this interim variable here just shows that a little bit better. So it replaces the group of 3 first, and then it will replace the 1 secondarily. Finally, we just need to clean up the rest of the numbers, and then we've got a nice list of all of the points that need to be summed together. Now you can see, after I've added this final replacement here, which just matches any number followed by a comma, noting that I do not include 0, because otherwise we would match something like this. It replaces that with just an empty string, so it removes the value completely. So here we end up with a comma delimited list of all of the points. Now the final step is just to add up the points, which we can do by splitting the string on commas and adding up the values with a reduce function. And boom, we've solved it. I'll just talk through this last section. So we split on the commas, and I just do a calculation here, which starts initially at 0 in this reduce function, adds the accumulated value to the next value in the array. Importantly, I'm just converting the value to a number here, because as shown on some of these, you end up with a trailing comma, which means there'll be an empty string at the end, which can be coerced to just 0 by converting it to a number. So this is the long version of it. But there's a whole bunch of optimizations that can be made to compress it down to the one-liner that I ended up with. So first of all, I've just pasted in the exact same thing without the console logs and just a bit more concisely, shorter variable names and things like that. So that gets us a good way there. And it occurred to me that I'm converting to a string with commas anyway, and then I'm splitting it back into an array, and then I'm adding up the array. Now, if I had the string that was delimited by pluses instead of commas, if you just simply evaluate the expression using the eval function, it would just add them all up. So by doing that, you can remove a lot of this code, and you can completely remove this whole line of code around adding it all up. I also had the further idea that this first replacement, if I was to add a capturing group around this section and make it optional, then I can add an argument here, let's just call it k, and then I can try to combine some of the logic of this replacement and this one, because in theory this will also match the exact same thing that this matches. And then I have a k variable here that tells me if it's a triplet or not. So I'm going to paste in the final version now and attempt to talk it through, but it uses essentially all of those concepts mixed together and allows us to merge all of these replacements into a single replace call, and all of this logic where we're calculating the points, I managed to get that into a single expression as well. Okay, starting from the top. So we've got this, which converts the dice array to a new array. We sort the array, and we join the array using plus as a delimiter. Next, we find all the digits. Now, bear in mind, a dice roll is always going to be single digits because they are 1 to 6 values. So this is always going to match a character that is between pluses. and we don't have to worry about multiple digits. So then I've got a capturing group, which is optional, which matches a plus and then the original character, a plus, and then the original character. Now that is optional, which means everywhere that matches, we're going to get the character, the digit, which will be 1 through 6. And then we're going to get a match here, which will be this section. And we can just, the way that I'm just using that is if we have a match, then it is a triplet. If it isn't matched, then it is not a triplet. So yeah, T is only ever being treated as a Boolean. So although it is a match and contains the actual matched text, I'm only ever treating it as a Boolean. So this first part of this equation is simply to resolve to a value of either 1 or 0. So it effectively is a way to turn on or off the points, because sometimes we don't want points, sometimes we do want points. Now the specific cases where we do want points are if we have a triplet, we always want points. And the only other scenario is if it's a 1 or a 5 that is individual, which is what I'm doing here. So I'm using modulo 4 because that solves what I need. Yes, because 1 modulo 4 is 1. And 5 modulo 4 is also 1, because you take away 4. And all other values between 1 and 6 result in a value that is not 1 when you do modulo 4. So this will be 1 if and only if it is a triple or we have a value of either 1 or 5. So then we multiply 1 or 0 by the value of the digit. Because if we look back here, if it's 1, 6, 5, 4, 3 or 2, or 1 or 5, the points are always some multiple of the original value. So we multiply by the original value. So the final thing that needs to be done is we need to raise it to some power of 10 to get to the correct points value. So we times by 10, and then we raise to this power. Now then, we can see that if it's a triple, we multiply by 100. So 10 raised to the power of 2. Except if it is a 1, we raise it to the power of 3. And if it is not a triple, then we raise it to the power of 2. So here we've got something that caters for the fact that 1 is special. 1 is special, and it's effectively treated like a 10, because instead of getting 100 points, you get 1,000 points. And if it's individual, instead of getting 10 points, you get 100 points. Whereas for a 5, for example, you multiply that by 10, you get 50 points. So 1s are effectively treated as 10s. So for that reason, I'm always adding either 1 or 0 here. If s is equal to 1, then I add 1. If s is not a 1, then I add 0. So it's basically boosting the power that it is being raised by 1. So multiplying by 10, essentially, if s is equal to 1. So by default, we raise to the power of 2. So we would get 100 here. So if it is a triple, then this will be true. we're inverting it with a not. So if it is a triple, then this will resolve to 0. Therefore, we deduct 0, and we are in fact raising 10 to the power of 2, which gives us 100. So 6, for example, would become 600, which is correct. Now, in the case that it is not a triple, let's use 5 as the example. If it's not a triple, S is 5, we times by 10, which gives us 50. 10 is raised to this power, so we start off with 2, we deduct this value, and because it's not a triple, we deduct 1, so 2 becomes 1, and then we add on this. 1 is not equal to, sorry, S is not equal to 1, therefore this is 0, so we add 0. So this resolves to 1, and we do 5 multiplied by 10 raised to the power of 1, which is 10, which results in 50. I'm just going to console log the output before we evaluate it. Because it's quite pretty to look at. So here you go. This shows it a little bit better. A triple of 3s, so we get 300. Triple of 4s, so we get 400. Triple of 5s, 500. You get the gist. So there we go. A nice, pleasing one-liner that is pretty much shorter than every single other solution. So pretty chuffed with that. I hope you enjoyed this video. If you have any other challenges you'd like me to try and reduce to the smallest possible length, I'm up for the challenge. Please be sure to comment with your requests, and I will speak to you soon.